Okay, that's 10 seconds. All right, so welcome everybody to the June 2024 drone software meetup. We're going to talk about how to get into MavSDK programming, drone programming. This is mostly what we talk about on the meetup is drone programming. We've kind of gone off track the last few months. We did a couple of things on security, which is great. Really nice to have a couple of people talk. But really the core job here of what we're trying to do is just to help you get going in different areas. So I thought it'd be good to just go back to looking at actual programming for a change. So MavSDK, I think it's pretty good timing on our part. It wasn't intentional wasn't intentional on my part at all, but basically what I wanted to do was look at some of the areas that we probably haven't looked at, we should have looked at. But there's a possible DJI ban going on in the US at the moment, so there is a vote tomorrow. I'll just show you some of the stuff that's out there. On June 12th, which is in the House of Representatives, and it would be the beginning of a total ban of DJI drones. Which is going to have huge impacts on the industry, massive impacts on the industry, because there's still 70-80% of all the drones that are out there. Lots of the stuff that is in use. Most of the work that we do is still on DJI drones, although we do quite a bit on some of the MAVLink protocol. And then the other news is the 530 members in the group. I think we're 534, which is so nice that I think we've almost doubled since the start of the year, which is great. But had a lot of speakers over the last few months. Hold on, there's somebody else in. But it's here's Victor. Okay, hey Victor, how's it going? So basically, back to normal. Let's just start talking about some of the coding aspects. I did say the DJI drone ban, so that's really kind of scary in a lot of ways. Change is good, change is bad. I'm not going to get political in this conversation at all, but this is a pretty dramatic change. So for the last 5-6 years, I would say most of the work that we did in the drone space, and we have up to 40 drone clients now, so we do a lot of drone work on the mobile space, has been with the DJI SDK. We're still bidding on jobs for the DJI SDK, but I have noticed last 12-18 months that much of the work has been looking at different platforms. So if you're not in the DJI world, you're almost certainly going to be in the MAVLink world. So MAVLink is the protocol that everybody uses in the PX4 or ArduPilot world. So basically what we have is we have a controller, and I'm not going to go into too much because I've done this a few times before in the past, and in the resources, I can talk about all the basics of MavLink and everything else. I do really want to just focus on MavSDK itself, just the coding. But in a nutshell, the protocol that's everything is communicating on the drone is MavLink. The MavLink has a Pixhawk controller typically, and the Pixhawk controller can be running one of two firmwares. One is PX4 and one is ArduPilot. And we're just looking at the PX4 for tonight. I do want to look at ArduPilot in the future. In the past, I kind of avoided it because to run MavSDK, you kind of had to run Python, which to me struck me as kind of odd to be having to run that on an Android phone. I think that's changed now, so I will be looking at it in the not too distant future. But essentially, MavLink is a protocol. Oterion have done a ton of work in that area. And one of the things that I'm going to talk about tonight is one of the Oterion guys have got a MavSDK Java implementation. He's also got a Docker for a headless simulator, which makes our setup really easy tonight. We're going to look at the client that they put out there too as well. But when I looked at the client, I thought it's a really good example, but it assumes that you know a little bit about MavSDK. So I wanted to kind of just put together like a really stupid, simple example of how do you do takeoff and landing? How do you just get some telemetry? So like altitude or position or velocity or whatever it is that we're trying to do. And because it's kind of a slightly different methodology that we use in MAVLink than you would do in DJI programming, and then just flying a really simple mission in the end. And then we can go back then after that, once we've gone through the little toy example that I have, because it's got really no error checking. It works, but it really doesn't it doesn't have any visual aesthetics. It's just basically a couple of buttons on a screen. And then you can see then that how good the Authorian client is, and we'll look at how that code's put together. So I just want to break down some of the basic functionality for our own, like I said, stupid simple app. We begin with how to take off and land, what telemetry is available, how we can read it, and also creating a mission. Because our setup is so basic, we won't be doing anything with cameras or other sensors. You don't need anything to do this. You don't need any equipment. We're basically just going to do everything on a laptop. So the protocol that's running around the drone is called MAVLink. I was trying to think today, what is the protocol for DJI? Didn't know whether it was Lightbridge or OcuSync, but it's a little bit more obvious when you're working on the Pixhawk type drones with PX4. You're just talking MavLink. We're going to use the Java implementation of MavSDK. The base implementation is C++. There have been times in the past where some of the, maybe something that you wanted that was in the MavSDK C++ wasn't exposed in the Java version. So you may have to actually write some NDK in C++ to get some of the lower level stuff going with the MavSDK. I'm not doing that here tonight. There is a question about whether we should use Java or Kotlin. Java is very definitely a second-class citizen in the Android world these days. I don't see any reason why Kotlin wouldn't work. But if you've gone through any of these sessions in the past, it's pretty obvious that a lot of the stuff that we would do on the MAVLink side of the house is a little bit finicky, a little bit frail. So I want to just make this as easy as possible for you guys to get up and running so that you don't have to worry about it. And then SITL is software in the loop, which is what we're going to do tonight, which is basically I'm doing everything on the laptop. We could use hardware in the loop where I could connect, an Orange Cube or a Holybro H7 and use that. So essentially connecting to the computer, the CPU on the drone, or we could just use the drone itself. We could connect to the drone and then get it to do hardware in the loop. But again, that's there's another barrier to entry after that. So I don't want to have any barriers. I just want people to, start playing with MavSDK, getting used to it. It's pretty easy to get working with this. And then that brings me to my last question is why not just use Q ground control? So for me, Q ground control is a difficult ecosystem to work with. Basically, what you're doing is you're coding the app in JavaScript. You're already working with an app that's already fully baked, by and large. Or what happens if you want to build something from scratch and you don't want to have, you don't want to dragging another entire ecosystem behind you. So if you followed some of the talks that we've done, there has been a talk where I've showed how to make some basic changes, customizations on QGC. And if you just want to do that, where you're trying to just change, you want to keep Q ground control, have a fully experienced ground control system, GCS, then that's great. But for me, what I wanted to do was I just want to build something from scratch. And I don't want to have any QGC stuff. I'm not a huge fan of the way that's the whole Qt environment, because QGC, Q ground control, is built on top of Qt. It's just I'm not a JavaScript programmer, I guess is what it comes down to. I'm not a huge fan of the user interface, so obviously the user interface here tonight's not going to be good at all, but there are opportunities to create better user interfaces and more customized versions than I think what you can do with QGC. Okay. So enough of my rant. So here is the simulator setup. This comes from an earlier meetup, which is in the resources. I linked to the YouTube. But what we have is PX4 running with the software in the loop. So that's what we have here. So we have this SITL. We have these things at the side. So the main thing that we're doing is we are replacing this Q ground control with other GCS. So this is going to be our area that we're working in. There is no joystick gamepad. Basically, it's just a couple of buttons that we're going to take off and land, that kind of thing. And then the simulator that we're going to use is we're going to use a headless gazebo, which is by far the easiest way that I found for setting up a simulator. So essentially what we have is we have our simulator, which is Gazebo, which is also running PX4. And then basically what we're doing is we are communicating it with via the MAVLink commands, which go across this port 14550. What does that look physically? So physically, it looks like this. So basically we have a laptop and then we just have an Android phone that's connected to it. Make sure that it's in developer mode, make sure that the USB debugging is turned on. HITL is different, the hardware in the loop. Basically what we'd have on the other side of the computer is we have it connected to an orange cube. Or I've been using the Holybro H7 flight controller lately because it's less than $100 and the orange cube's what, $250 now. So a great way for learning, or a great way if you want to go to the next stage. So what's the pros and cons of SITL? So with SITL, for what we're doing tonight, it's great. What we're doing is, some very basic commands, getting the telemetry, doing a simple mission. But what happens if we actually want to connect a sensor such as a camera? Because typically that's what you're doing a drone anyway. It's a flying camera, so you're trying to get whatever the video is from the camera and then process that some way. So if you want to do that, then you have to go the HITL route where you have the Pixhawk, which is going to be the other side of your laptop, and then that's going to be connected to whatever sensors that you have, if it's a camera or searchlight or whatever it is that you're trying to do. Okay, and this is our stupid simple setup. So the MavSDK Java is on github.com/MavLink. The Android client that I'm going to talk about a little bit in a second, which is there are two examples that Jonas, who's the guy who gave it to us, his last name, and I want to completely destroy it, Votharin, Jonas Votharin. So basically he's given us the Android client, which allows us to have a kind of the kind of example that you expect. It's got Mapbox, it's got running it, connecting to a backend SDK, MavSDK server, and all that we're doing is basically this is a client. So our Android, the same as any other Android app, is a client to whatever the backend server is. So the backend server, in our case, is the headless gazebo. The gazebo being the simulator that we're going to use. And if you joined me in one of the early things that we did with the simulators, you can. I did a talk at a PX4 conference last year. I think it was last September, where I did a dry run in this meetup group. It can be really difficult to get it up and running, but this is a one-liner. So if you've got Docker installed, basically what you do is you do Docker run, and then you're downloading Jonas's example of the gazebo, and then all you need to know is whatever the IP of your phone is and the IP of your computer, and then you're good to go. And if you want to get the app running, there's a small change that we have to make in the code, where we have to actually point it at the port that we're trying to do, which is the port that you would see from behind here, which is the 14550. Okay, so editing the code itself, just a really simple change. And then we end up with our sample client, which is, I'm just gonna get it to run. So this is the MavSDK Android client. We're going to choose a couple of waypoints, and then we just do start mission. So we have to, at the top, you can see that we just wanted to tell it to talk to the MavSDK server, which is, in this case, is our backend simulator, and then we just get it to tell it to fly. Once we go through the example today, I'm going to return to this again so we can have a look at the code. It's a pretty good, client. I've seen a lot of them. It's one of the, we looked at the Parrot one probably very early on in the drone meetups, and their client, their example did absolutely everything with the Parrot drone. So it did from start to finish. everything that you could possibly do. And sometimes that's too complicated. This example, I think it's a little bit better because it's showing you how to do things like communicate with the backend server. It's showing you how to do things like set up a map box, set up some waypoints, creating a mission, land and return, that sort of stuff. So I think it's a really good example. But I still want to break it down a bit further. Okay. Let me just break out of this and look at the code for a second. Okay, I think that's the one. Note to self, don't move things around before you start your startup. Okay. All right, so we have maps activity, and then we have maps view model. So the maps activity is, this is the main activity. So when it starts up, it's basically, it's got a couple of map views, it's got a couple of buttons. There's a lot of error checking going on, which is great. It's got all the different life cycles. I still think, I will return to the second, I still think this is a little bit harder than it needs to be for what we're trying to do, which is why I kind of went for a really stupid simple version of this whole thing. So if I go into the activity main.xml, I can show you what our app looks like. So our app basically has 1, 2, 3, 4, 5, 6 buttons. So the first one is the same as the button that was on before. We have a MavSDK server. We have a takeoff and a landing. I put in a couple of parameters in there. And then the last thing is just a simple mission. If you are used to Android programming in any shape or form, you'll know that basically the way it works is that you have, well, the way it used to work, it's kind of changed now, but I'll get to that in a second. So the way that it originally worked is that we had a resources file, which was our activity main, which essentially is code for each of the different buttons. So you have different types of layouts. I've gone, like the really easy ones are linear layout and relative layout. So I've gone for the really simple one. We have the buttons here. We just define them. We give them a little bit of text to say what they are. So that's our layout. So the layout for what you do, 80-90% of what you would do in the old days was within each of these layout files. When you start a new empty project, you just go Android start empty project, and then it's going to give you a main activity and an activity main. So I basically took what was in here before, which is just a simple hello world, replaced it with the buttons. And then on our main activity, kind of replaced what all the, this is, you get a method which is called onCreate. So basically what I took with this, it goes out and pulls in the activity main, and that's how you get your layouts displayed in Android. I need to be able to see what each of these different buttons are. So I do find view by ID, and then within those, I set listeners for each of the different buttons. So depending on what the person is clicking on, so if you click on the first one, which is the takeoff, which is connecting to the server, it's just going to call the initialized server and drone. And essentially that's what the code is to begin with. So let's go back to my presentation. Okay, and then this one is actually using, this is the PX4, the simulator. In this case, it's JMavSim. I didn't do any, you don't need a headless. There's no reason why you couldn't just have one of the, set this up, but it would probably take us most of the meetup to be able to get through setting this up. So that's why I've gone with the headless stuff. But you can just see as it's working through, this is, oops. No, I missed it. So this is kind of the thing you see as this is the Android client, this is the Auterion one. As it's taking off, it's climbing to 5 meters, giving you the kind of information in the background. And then as it's got various different warnings, and then it's going to land at its current position. So that's what we have if we're going to use the JMavSync. My one is slightly different. I can get out of this now again. So assuming that you have Docker on your machine, so assuming that you have your Docker set up, that's not going to work. In order to get our simulator working, I can find the right slide. Going back to my simple setup again, I'm just copying it. To get it to run, it's this command. The only thing that you have to worry about is you got to make sure that you do an IP config to know what your machine is, and then you got to make sure that you're doing a that you're checking on your phone to make sure that you have the IP address of your phone correct. So if we want to take it off, so okay, so this is I'm doing everything on the server, so I want to be able to have my little client, my basic client, be able to talk to this. But everything's up and running, so that's kind of simplified dramatically what you need to do in order to be able to get your simulator up and running for MAVLink. Okay, let's go back to where we were. If you do want to run the client, I will tell you that it's probably about 3 or 4 years old now. So if you're very experienced in the Android world, you'll know that Android Studio is moving at a pretty ferocious clip. So you can't just download the app and get it to run, because it's going to ask you to upgrade the Gradle plugin. So if you're looking to get that client working, the secret is to go into Android project structure once you've got the project open, and change the plugin version to 4.01 and the Gradle version to 6.5. Otherwise, you're going to spend 15-20 minutes chasing your tail to make sure that the dependencies are right. Just go with what they originally have. Don't do any of the upgrades, and the client works great. It's forever asking you to upgrade everything, but that's just going to lead to the code breaking. So my recommendation would be, this is the sample client from Auterion, the one that's on MavSDK. Make sure that you're using these versions of the of Gradle. So quick 2-second intro to Android development. Like I was saying, so at its most basic, you need 2 things in Android. You need a layout file, which is activity.main, activity_main.xml, and you need a main activity. So activity_main.xml is basically what your app is going to look like, and you can use this drag and drop interface to do that if you want to. If you're a hardcore programmer, you're just going to go into the code like I showed you and then edit the XML file directly. You also need an activity file, which is the main activity.java, that makes the layout do things like enable a button or call a function or method, which is what we said before. Now, in the world of Android, as I said, it's moving at a ferocious rate. Most people don't do this anymore. So if you're doing an app from scratch, you're probably going to use Compose. But just for ease of use, I thought it would be easy just to go with the old standard, which is activity_main.xml, because we're not really doing anything very extravagant today. Okay, so rather than talk about the sample app, let's talk about something really simple. So we want an app that will start our communication with the backend MavSDK server, and we want to be able to take off and land. So what we need to do is we need to create a new project, choose the empty activity project. Normally when that runs, you just get a little hello world in the center of your screen. It's great for starting off doing Android. Gets all the devices set up and everything that you might need. The other thing we need to do is we're going to edit that XML layout to add our own buttons. We're going to add the dependencies in the build.gradle. That's changed as well, so it's worth talking about that just for a second. And then we're going to update the main activity to initialize the server, and then we're going to have a takeoff command and a land command. Okay, so just for those 3 buttons, when we hack our XML layout, we're going to change it to, it usually comes up with a constraint layout. We're going to give it a relative layout. So there's a linear layout, relative layout, constraint layout. Linear layout and relative layout would be the two simplest ones, and relative just means that you're putting the buttons relative to other buttons. So I'm just giving it each time the first button I have is button server, and then I tell the layout below is, I'm going to say the button takeoff is going to be below button server, and the button land is going to be below button takeoff. So really easy to set up. You get rid of everything else that's in there and you just use those. Then the code for main activity.java, it's going to create the start of the code, which is going to give you this on create. And this is how it pulls up its layouts. So it's going to say set the content view to the activity main.xml, which is what we were just looking at. So we have 3 buttons to begin with. We want to get a reference to each of those buttons. So we do find view by ID. We set an on-click listener for each of those. So that way that if one of those buttons is clicked, then we get an event that's passed to main activity.java. And with that, essentially what we're going to be able to do is to do whatever functions we want, which in this case would be to call initialize server and drone. And then we do takeoff and land. So initialize server and drone. Fair warning, there is no error checking here. One of the things that I do know that I need is destroy server and drone, because I found when I've been playing this for the last few days that if you run it once or twice, essentially the port's still hanging because something's still talking to it. So I will need another button, which I'll add after the talk, but just for sanity, but this works. So we have initialize server and drone, gone up in MavSDK. We pointed at the UDP port that we want, 14550, which goes back to that SITL diagram. Just make sure that's set up. And then to get everything to take off, we have this command. So in the resources, I do give a list of where all the APIs are, where to find all the information. There's less information on the Java side than there is in C++, but it's still pretty obvious what you need to do based on what we had before. So we're going to arm the drone, and after we arm the drone, we're going to start an action, which is take off and subscribe. The methodology of communication in almost everything we do in the MAVLink world is publish and subscribe. So we're using Oryx Java in a lot of what we do. So even on something as simple as takeoff and land, we're basically subscribing to whatever the messages are that MAVLink are sending us. It's much more obvious when we look at some of the telemetry stuff that we're looking at, because really then what we're doing is seeing more and more data. In this case, it's just going to give us one piece of information back to say drone has taken off, and then when we land it, it's just going to say drone has landed. All the code is in the link on the resources if you want to play this at a later stage. So the dependencies in Android have changed again. So in the past, it used to be whatever the version you put in the dependencies. Basically, what you have to do is add it through the GUI now and tell it which version of MavSDK that you want. In this case, I'm on 1.4.x. The 2.x is out, but maybe in a future meetup, I'll go and update that to the 2.x, but I'm just working off 1.4 at the moment. Okay, so if you're new to Android dev, this dependencies is in the build.gradle file. There are 2 build.gradle files. This is one under the app folder. And Android, like I said, has changed. Google has changed the format again, so you're going to have to go into the IDE to see what version we're importing. And when all of these other dependencies, they're out of the box. So we're just adding these 2. Okay, and if we run the app, because I said this is pretty low level, basically what I'm just pushing everything out to Logcat to see what's going on. Because we're restricting ourselves to this headless environment, we can see that we can connect to the MavSDK server using Android Studio's Logcat. So basically, we start the app, we click on the app, assuming the port is not taken by something else, it will connect and you're ready to go. Okay, if we ask it to take off, you see 2 things that go on at the same time. We see in the Logcat that it says that it's armed and it's going to just take off to a minimum altitude of 2.5 meters, and the other information that you get back is takeoff detected. So you can see the subscription thing. You subscribe to this thread, and this thread is basically passing you back the information about what's happening. And then we can see the drone taking off in Logcat and in the simulator itself. So similarly with the landing, if we click the landing button, it's going to say landing detected, and then it's going to disarm the drone. So the drone gets armed, and then the next action is it either lands or it takes off. And the one underneath here is this is what we see when we run when we look at what's going on in our headless simulator. It's basically just going to tell us all the information about what the server sees, and as it's landed, it closes the log file and everything's completed. Okay, the second thing I want to talk about is telemetry. So that's great. So we have our headless simulator set up. We have MavSDK running. We have a taking off and landing. What else can we do? So there's a ton of information that you can get from the drone. So it provides a variety of telemetry readings and data. So we have position. So position is latitude, longitude, altitude. We have the velocity, what ground speed is, what the airspeed is. We have the attitude, which is the roll, pitch, yaw. Battery level, well, we don't really have any batteries in SITL, but if you did have a drone connected, it would give you the battery level, what the voltage was, and the current, GPS info, so the number of satellites, which is really important. And then what the fixed type is. We have health, so that health could be the health of the different sensors, could be GPS, could be the gyroscope, the accelerometer, that kind of thing. And it will also give you the system status. We have the different flight modes, so that could be manual or emission. We have the actuator control, so whatever the outputs are that you're getting from the motor. Our home position, so if we want to return to home, RTH, return to land. We have the home latitude, longitude, and altitude. So land detector, whether the drone has landed in free fall or moving, RC. So do we have any remote control channels that we're talking to? Do we have any distance reading from onboard distance sensors, camera information? So what camera information do we have? So what is the status, the settings? What mode are we in? Are we taking photos? Or are we taking video? And then the mission progress. So missions are really important in drones. So you want to set up an automated flight. You want to basically do an orbit. You want to set what the waypoints are, like we did with the Android client, to get that to fly. So you want to know what's going on the mission as that's going on. How many items, how many waypoints do we have, or items do we have? How many have we gone through already? Is the mission completed? That kind of thing. So to show you how to do basic telemetry readings, I thought altitude was probably the first one to start with. So we want to know, we're just going to go after our position stuff here. So we're going to go for the altitude and then our lat long. So we're kind of using a Java construct here. So we have our method, which is called get altitude. So the first part of the method creates a flowable object named altitude. Flowable is a class from the RX Java library, which is the Java implementation of the RX reactive extensions. So it's a library for composing asynchronous and event-based programs by using observable sequences. So basically what we're doing. So altitude is a flowable that would emit an altitude of the drone as a float. The altitude is obtained by the get position over here, and then get position method on the telemetry object of the drone. This method returns position object, which is then transformed into a float representing the altitude using the map operator. And then the map operator applies a function to each item emitted by the flowable. In this case, the function is extracting the relative altitude in meters from the position object. So get relative altitude meter is what we're doing. So basically what's happening here is that we're getting a lot of altitude measurements at a fair old clip. And this float is basically getting us each of those different measurements. And then we're publishing them, and then we have to subscribe to them. So the second part of our code is this method, which is our altitude subscribe on. So subscribing to a flowable means that the subscriber will be notified of any items emitted by the flowable. And in this case, the subscription is done on the scheduler, and the notifications are observed on the single scheduler. So the scribe method takes the consumer, which defines what to do when an item is emitted by flowable. And here, what we're really taking the most basic thing is we're just logging what the altitude is based on what's coming in. So we have get the altitude of the drone. How do we do that? We create a flowable, and then we subscribe to the flowable. And then what we're doing is we're just taking out each of those single observations, and then we're just throwing it out to logcat each time it happens. Okay, don't know if I missed somebody there. Okay, all right. Let me get back to where I was. And then we get our altitude measurement. Okay, the second thing I wanted to do is to get was do the same thing. I want to know what the lat long was on the Docker simulator, so I thought I'd check. Same again, we have our flowable using the same thing. In this case, I'm doing position, which is going to give me the position dot get latitude degrees and position dot get longitude degree. We're doing a observation, single observation again, subscribing to the consumer, and then just outputting it to logcat, same as we did before. And this tells me that my latitude is 47.39 and my longitude is 8.55. So when I put that into just any old website that gives me, I see that, yeah, it looks like we've got Otirian's lat long here. So there's no reason why you couldn't set that yourself. You can set it in environment settings if you want to not be just using this, but I just thought it was interesting to see how to pull that. And then I need to know if I'm going to set up a mission, I need to know where we are, latitude and longitude. So any of the items that I want to add to my mission planning have to be really close to whatever that latitude and longitude is. So that's basically the reason that you'd be looking for that. So our simple app now has the following screen. So we have what we had before, which is our MavSDK server. We have a takeoff and a land. We have another button for get altitude, another button for get position. And then the last thing that I wanted to do was to do a mission, which is starting an orbit flight. So this method, basically, I have a single item here, and there's also a mistake, which I'm going to have to talk about a little bit as well. So basically what we do is we set up a mission item. This is I have to go and look through all the different parameters for this. But basically we have our lat long. Let's have a look at the code. I think it's more obvious in the code. So this is our latitude degree. We have our longitude degree. We have our relative altitude. We have the speed. Is it fly through is through. And then we don't have a camera because we're doing SITL, so there's no camera action. I changed this to make this a drone orbit. So it's just got a radius of 10, so it's just going to fly around. So we have a single item in our list of items. Normally when we're doing a waypoint mission, we have a number of different items. But in this case, we're just going to do an orbit. And then we have add that to the mission plan. And then we set return to launch after mission. We upload our mission, which is this really simple mission there, and then start the mission and then subscribe again. And that is the easiest mission that you'll ever see in drone programming. Okay, what else can I take? Maybe it might be time to actually look at this running. So assuming this works, what you get is takeoff detected, mission finished, loitering, landing at current position, then landing detected. Okay, so let me see if I can run a couple of these now. So let's start with this. I have my phone connected, so hopefully this works. Let me just start this here. Gradle build is running, so I haven't run this in a while, so it's doing everything from scratch again. It's launching on device. Okay, so now it's on my screen. Can I mirror this? Okay, so now we have MavSDK. So the first thing I want to do is, well, let me see if I can get this up and running too. Just make sure that's connected. Okay, so I can now see that the MavSDK is now running, listening on port 35995. Don't worry about whether it's suitable for takeoff or not. I'm going to do a takeoff just by clicking the takeoff button. So takeoff detected. Okay, let's get the altitude while we're here. And then it just flies. The altitude just goes all over the place. Okay. Okay. You can do position as well, and then position is going to start filling that up too as well. Okay, let me stop that. Let's start it again. This is probably where I'm going to run into issues. Go look up. See if I can connect to my MavSDK. Okay, looks like it might be there. And then do a set orbit flight. Yeah, it doesn't look like me. Doesn't like me. No. Okay. I think I'd have to reboot to get this going. Let me see if I can get the other one up and running while we're here. So this is the Auterian version. You know, I basically just copied at its most basic level, exactly what they were doing here. So I have each of the different buttons, which they have set up in their activity maps.xml. So we're just calling it slightly different. So it's got Mapbox on top of this, which is you're really going to want to. We have within a Mapbox, so it's using Mapbox. It's got a button, which is just basically our run or destroy MavSDK server. It's map activity. Did it run? No, it's still going. So within here we have our own create. It has a bunch of items in its nav bar. So we have a disarm, we have a land, return home, and takeoff. It's got some great information here about if you want to set waypoints on the map box, how it uses those waypoints and adds those waypoints to the mission in order to be able to create its own mission items and start the mission. It's doing, my starting the MavSDK was just basically doing this. Yeah, it's not letting me go. Never mind. I can get it running again later, but I think I'm connected to too many things at the same time. Okay, let's go back to what we have. So what resources do I have for you? So this is the MavSDK Java. So github.com MAVLink. There are lots of different implementations. There's a Swift implementation. There's a C++ implementation, which is where everything is built on top of. There's a Python. So there's lots of, you just want to play with it in Python yourself. There's lots of ways to do that. If you want to just talk to it from a Java client instead of from an Android client, you could do that too. The two examples in here are the Android client and the Java client. I didn't really change anything there. If you want to check out so it's, I put it under my name. So it's Godfrey Nolan MavSDK. The code's out there. It's a good place for you to start. This is if you want to find out more about simulators. So we did this PX4 simulator unlocking drone development, and that was in October. So the video's out there if you want to try that too. We had some downtime, people on the bench. So a year or two ago, we basically took this example and turned it into an actual GCS that does things. It doesn't have any cameras attached, but it's just a bigger implementation of what you can do. And then I have this DJI band too as well. So the fate of the world is decided tomorrow for the DJI drones, although I think it's probably going to be a bit later. Okay. I said, GCS client, actually doing some more work in this recently, just based on our wondering what on earth is going to happen with all the DJI stuff. So some resources, here's the links that we have. So that's the previous meetup. Here's where we are on Google Play. This is the MavSDK stuff. And then there is some documentation that's hanging off the MavSDK Java. If you want to see more information on each of the different things that you can do. But basically, if you think about what you're trying to do with a drone is, at its most basic, you want to be able to get it to take off. You want it to be able to land. You want it to be able to read whatever telemetry it is. And then essentially you want to be able to connect to the camera and get whatever video it is from the camera. But I think of all of the SDKs that I've used, MavSDK is probably the simplest one. And I just wanted to put it out there just to show you guys how to get started and how to avoid the, oh my God, I'm going to spend 2 weeks trying to get the simulator working, because we did have somebody spend an awful lot of time getting a simulator working in the past. So we're very happy with the headless simulator, and it looks like that it's getting updated on a fairly regular basis. So that would be my first port to call if you want to start doing some MAVLink dev. And with that, I'm just about finished. Does anybody have any questions or any comments? Nope. Well, okay. Thank you, Eric, as usual. Thank you, Laura. And all of this stuff. Thanks, Rod. Nice to hear from you again. And then all of this, the slides, I'll put them out onto the meetup tomorrow. The video will probably be up on YouTube. I think it's already on YouTube because we're doing it live. So if you want to see any of the points, or if you want to go over what it is. And then next month, we'll probably do coding again. I was thinking about doing something on the DJI Dock 2, but I'm going to wait till I see what happens tomorrow, whether I do something more with DJI or whether we do something with one of the other SDKs, because I think if the DJI band does start to look like it's coming into place, then we'll basically just be looking at as many SDKs as we can to help people get some alternatives to the DJI ecosystem. Okay, thanks everybody. Really appreciate your taking time and hanging out with me this evening. Thanks again. Bye now.